Many of us are used to turning on the sink or shower and having water readily available. But think what would happen if you went to get a glass of water and nothing came out. Many Americans would be outraged, as the constant availability to water is a luxury we Americans have taken for granted. But how often do we stop and think about where that water came from? Not only this, but how did all that water get to the purified state it's in? And who's to say what clean water is anyway? Find out now in Water Purification. According to a study done by the United States Geological Survey, an average of 80 to 100 gallons of water are used per person in a single day. With the ever-growing population of the United States currently around 320 million people, that is an average of 32 billion gallons of water a day used solely for consumer purposes. So where does it all come from? Depending on where you live, your water can come from a variety of sources. One of the most common sources is surface water in rivers, lakes, or streams, followed by groundwater collected from aquifers. This water, however, does not travel directly from a source straight to your sink. First, the water must be treated and purified to meet a specific set of standards. In 1974, Congress passed the Safe Drinking Water Act, which was later amended in 1986 and then a second time in 1996. This act gave the Environmental Protection Agency, or EPA, the right to standardize the quality of drinking water. Over 90 different contaminants, ranging from various inorganic and organic molecules to microorganisms and disinfectants, are given maximum concentration levels. Publicly supplied water must have concentration levels under these standards in order to be distributed. So how is water purified to pass the EPA standards? The process begins with coagulation and flocculation. This first step involves adding positively charged chemicals to a mixing tank, which holds the raw water. Commonly used coagulants include aluminum sulfate, ferrous sulfate, ferric sulfate, and ferric chloride, all of which dissociate when reacted with water to form positive ions. These ions bind with unwanted negatively charged particles in the water, creating larger particles called floc. Due to its heavier density and weight, floc settles to the bottom of settling tanks. This settling process is called sedimentation. The floc can be removed from the water now that it has settled to a separate layer. The settled floc, or sludge, is pumped out from the bottom of the tank, leaving the water behind. In a process called filtration, multiple filters, all with different porosity and composition, remove some of the remaining large particles from the water. Some examples of filters are anthracite, sand, and gravel. After filtration, the water is almost up to EPA standards. The last step before the water can be piped out is disinfection. This step involves a disinfectant being added to water to remove any last bacteria or parasites still remaining in the water, such as salmonella. Usually chlorine or chloramine is used as a disinfectant. After disinfection, the water is finally in a pure enough state to be released for public use. Running water through large treatment plants isn't the only way to purify water. Many consumer filters are available to further reduce the concentration of unwanted toxins in water. Most consumer filters sold today use a process called adsorption to purify water. Brita water filters utilize adsorption in their filters. Adsorption is the chemical process in which contaminants unbind from water molecules and bind to the filtered media. Carbon-based molecules are mainly used to filter out unwanted chemicals. Zinc, lead, asbestos, and chlorine are a few examples of chemicals that adsorption will help to remove. There's a variety of ways to purify water. No matter how your water gets purified, it is important to make sure you are not consuming any toxic chemicals. To find out more about the quality of your water, go to www.water.epa.gov/drink/local.